All right, let's begin. Kinematics in one dimension. So again, this is pretty much review of grade 10 concepts. By the end of this little lesson here, you should be able to define what a frame of reference is, and you should be able to convert from meters per second to kilometers per hour, and kilometers per hour to meters per second. Let's go. The motion of objects, baseballs, automobiles, joggers, and even the sun and moon is an obvious part of everyday life. Motion was undoubtedly the first aspect of the physical world to be thoroughly studied, and this study can be traced back to the ancient civilizations of Asia Minor. We're talking about your Egypt, your Persian, Turkey, Greece area, that area there around the Mediterranean. Although the ancients acquired significant insight into motion, it was not until comparatively recently in the 16th and 17th centuries that our modern understanding of motion was established. Many contributed to this understanding, but as we shall soon see, two individuals. I'm really just trying to get through this. If you could just wait. Two individuals stand out above the rest. Galileo, who lived from 1564 to 1642, and oddly enough, Newton, who was born the year that Galileo died. The study of the motion of objects and the related concepts of force and energy forms the field called mechanics. Note that it's bolded. If you have a highlighter, you might want to do that. When I asked you back at the start of this first unit, what is physics? Most people talk about the study of motion. What they're really talking about is not physics. They're talking about mechanics. Exactly. Mechanics is customarily divided into two parts. Kinematics, which is the study of how objects move. Are you guys going to talk to the whole thing here, or? No. So? Kinematics is the description of how they move, and then dynamics, which is the study of why they move. So when we get into dynamics, we're going to be talking about forces, which was Galileo was more the kinematics guy, Newton was more the dynamics guy. We start by discussing objects that move without rotating. Such motion is called translational motion. When Mitchell throws a strike to his wide receiver, I'm guessing that the ball throws a pass to a receiver, the ball rotates. That is not translational motion. Okay? Translational motion is without any rotating at all. We'll mainly be concerned with describing an object that moves along a straight line path, which we call one-dimensional or rectilinear. In grade 12, we'll describe motion in 2 or 3 dimensions, basically when we're going to start talking about projectiles. Okay? For now, we're going to limit ourselves to vehicles and trains and things that just go sort of straight. Okay? Things that go straight. Speed and velocity are words we often use interchangeably in everyday language. You guys know the difference already. In physics, we make a distinction between them. For now, we discuss only speed, which refers to how far an object travels in a given time interval. If a car travels 240 kilometers in 3 hours, we say that its average speed was 80. How did I get 80? 240 divided by 3. In general, the average speed of an object is defined as the distance traveled divided by the time it takes. Or in other words, V bar equals D over T. Put a box around that, you're going to be using that lots. You used that in grade 10.
Yes, you did.
Let's see if you can use it now. D stands for distance, T is for elapsed time, and for the speed. The bar over the V is standard symbol meaning average. Anytime you put a bar over something like that, it means automatically average. So average velocity. So for example, can you solve this little problem? How far can a cyclist travel in 4 hours if his average speed is 11.5? I need you to type in an answer.
Okay, I got an answer.
Got an answer for me, Alex? Here we go. Correct answer is 46.
Who answered wrong?
How do you do that?
How do you answer wrong?
Well, maybe you should hurry up. No. Get going. Quit wasting time. 11.5 is equal to D over 4. D equals 4 times 11.5 or 46 kilometers. Okay? That I expect, and I was pleased to see that everyone got that. Most everyone. You've got to be able to handle stuff like that. Okay, let's talk about reference frames. Let's talk about reference frames, Mitchell and Lucas. When riding in a train, you may observe a bird flying by overhead and remark that it looks as if it's moving at a speed of 20 kilometers per hour. Who hasn't sat on a train, looked out the window, and tried to figure out how fast the bird was flying? Anyone never done that before? Excellent. All your hands should go up. No one's going to do that. It's crazy stuff.
I've been on the train before.
Have you? I've been on trains. Trains are nice.
I like trains.
So when you're on that train and you observe the bird flying at 20 kilometers an hour, do you mean that it's traveling 20 kilometers an hour with respect to the train or with respect to the ground? What do you mean? And what do I even mean by with respect to? Let's investigate. Every measurement must be made with respect to a frame of reference. Some point. Where are you standing? For example, while on a train traveling at 9 meters per second, you might notice a person walk past you toward the front of the train at a speed of, say, 2 meters per second. So here you are, you're on the train, and this person walks past you at 2 meters per second. With respect to the ground, that person is moving at what speed? How fast are they going? You're sitting on the train, which is going at 9 meters per second. Someone walks past you to the dining car or to the bathroom or something, walking at 2 meters per second. With respect to the ground, that person is moving at what speed? Let's see, how we do?
Yeah!
It's right there!
You get that wrong!
If you're sitting on the train that's traveling at 9 and a person walks past you at 2, when I say with respect to the ground, in other words, someone standing on the ground, if that person on the train is standing beside you, they see 9. If you see them walking at 2, they see them walking at 11. 9 plus 2. The frame of reference is different. Okay? This is the person's speed with respect to the train as a frame of reference, the 2. Okay, this should be 11. It's always important to specify the frame of reference when stating speed. In everyday life, we usually mean with respect to the earth, without even thinking about it. But the reference frame should be specified whenever there might be confusion. If you're driving down the highway, and you see the sign that says maximum 100 kilometers per hour, in little fine print, if you get out and look on the highway, it should say there underneath, with respect to the ground.
What?
It should say that on the sign.
Like the 100
It doesn't say that.
The 100
Why?
If you go to court and they say you're traveling at 125 kilometers an hour, you could say, well, with respect to what frame of reference, sir? You're still going to get the ticket, but you'll feel smart.
They'll be like,
Yeah, exactly. They'll probably put cuffs on you. Don't do that.
all right, well, you're going to go to jail.
All right. Give me a little more time here.
Holy shit.
Just the values of other physical quantities also depend on the frame of reference. We've talked about frame of reference already. You just didn't realize it. When we did vectors, and I said something like east 30 north, what's my frame of reference? East, or that point right there. We've already talked about this. There's no point telling you that Riding Mountain National Park is 100 kilometers away unless I specify from where. Distances are always measured. How come every time I start speaking, someone else starts speaking? I hope you're enjoying this more than I am.
I really like this stuff.
Distances are always measured in some frame of reference. Furthermore, when specifying the motion of an object, it's important to specify not only the speed, but the direction. Blah, 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 blah. We've already done all this stuff, right? Objects positioned to the right of the origin of coordinates on the x-axis are usually said to have an x-coordinate with a positive value. You guys should know this already, right? Positive there. Positive y is there, negative y, negative x there, right? All stuff that you know. At any point on the plane can be specified by giving its x and y coordinates. In 3 dimensions, a z-axis perpendicular to the x and y axis is also used. When you're doing 3-dimensional motion, axis. Yeah.
AX here.
That's one way to spell it. Yeah, that's an axis. No, that's plural. You got your x, left to right. You got your y, up and down. Which way is z? Out at you like this. Positive is out, negative is in. Okay? Does anyone ever need to know that? Any job, any occupation? 3-dimensional. Architectural, maybe a map. So I'm thinking about a computer engineer. If you're trying to create a 3D image in a movie, right? You have to understand that third reference frame as well. Although most measurements are made in reference frames fixed on the Earth, it's important to recognize that reference frames other than the Earth are perfectly legitimate. For example, I did. Scientific measurements are sometimes made on moving ships and spacecraft and on the moon. I wonder what this is. I actually do wonder because I don't remember.
Bjorn.
Rubbish guy.
Just.
What is a frame of reference? A frame of reference is the perspective from which an observer views a situation.
Oh, what
There is
is
no
it?
absolute.
At the end of today, you need to be able to define a frame of reference. Can you do it right now? Let's just play this again. Maybe get out a pen, because you might want it.
What is a frame of reference? A frame of reference is the perspective from which an observer views a situation.
That's really bad.
I'll read it for you. It's right there. I can see it. You probably can't see it. What is a frame of reference? A frame of reference is the perspective from which an observer views a situation. Perspective from which an observer views a situation.
Use a situation.
Are you stationary right now? Are you at rest?
Yeah, I'm observing someone.
Am I at rest?
No.
To you guys, I'm at rest. I'm standing here. I'm not moving. If I start walking, your frame of reference says that I'm moving, right? If I just stand at the front of the room like this, I'm not moving. Unless, of course, you are not on the Earth and you see the Earth rotating, then I'm traveling at a pretty good clip. Or if you're outside our solar system and you see the Earth whizzing around the sun, I'm moving at a pretty good clip. Or if you're outside our galaxy and you see our galaxy rotating around its center, we're moving at a pretty good clip. It's all about your frame of reference. I'm a little far away now, yeah.
There is no absolute frame of reference in our universe, no stationary platform from which we can observe all other motion. The only constant measurement we have is the speed of light. There are 2 types of frames of reference. They are known as the inertial frame and the non-inertial frame. Let's look at the inertial frame of reference.
Okay, we've done a little of this already. I just want to make sure we're all on the same page here. Quite often a question may list speeds in kilometers an hour. Often that may need to be converted to meters per second. So with your clicker, tell me, what's the rule for converting kilometers per hour to meters per second? Is it times by 3.6, divided by 3.6, add 3.6, or times by 100? What is the rule for converting kilometers per hour to meters per second? Correct answer is B. Write that down on your sheet. Converting kilometers per hour to meters per second is divide by 3.6. Okay, it's right there on your sheet. Fill in the blank. Let's see if you can get number 4 right now. I hope you can get it. Meters per second, 2 kilometers per hour. Hope, yay! Everyone got it. I expect everyone to never ever make that mistake again. Okay, I'm done. There are a few questions there. Make sure you can do them. If you want to sit back and do nothing the last 15 minutes, you be my guest. But you better know how to do that stuff. Okay? That's what we're supposed to do today, is be able to convert meters per second to kilometers per hour and vice versa. I'm going to give you those exam answers. Actually, we can give you those answers at 3:25. That will not take you more than 9 minutes to complete.
What are you talking about?
I'm talking about completing those in the next 5 minutes. Go. Okay, quickly here. Defining mechanics, kinematics, dynamics, translational motion. Mechanics is basically the study of motion, really. Nate, I'm giving answers. Now's the time to be quiet. Mechanics is the study of motion. Kinematics is the study of how things move. Dynamics is the study of why they move. Translational motion, motion without rotating. Know those words. What's the formula for average speed? Or you should actually know most of them from grade 10. Average speed is V equals D over T, and I expect you to be able to use that on a regular basis. What is a frame of reference? Give an example. Frame of reference is some point. What did she say? How did she put it? Exactly. Perspective from which an observer sees a situation. I would say it's some point that an observer might take a measurement from. Right? You're saying how fast they're going or how far away they are from that perspective. Convert those to meters per second. Every single one of those, how did you do it? You should have divided by 3.6. And everyone at number 5 there, you should have multiplied by 3.6. Okay? I expect you to be able to do that. Okay? Moving on tomorrow. Pretty sure. Here's how I remember it. If you're needing to know how to remember it, kilometers per hour to meters per second. Big units, kilometers and hours to meters per second. Go from big to small, you're going to divide. And if you're going the other way, you're going to multiply.
I'm pretty sure it's multiplied for like number 4 though. Convert to MS.
So you're going smaller. You're dividing.
Crap sake.